I think we're going to do a quick little review of Boolean logic, and then we'll kind of get on to maybe this this random walk. I may save the random walk for next time. We're not doing any randomness in the next couple of labs, so we do have time. And this Boolean stuff is pretty important. The first thing I want to point out is that when we talk about Boolean logic, there's this thing called truth tables, and you'll get into them, a little bit more. Remember, by the way, George Boole invented this in the 1840s. It reduces classical logic to an algebra, and it's a really friendly algebra because there's only two values, true or false. If you guess, you get a 50% chance of getting it right. For our purposes, we need to be able to convert between things like numbers and strings and characters and floats to Booleans. So we have these comparison operators that get us there, right? This returns true if the first value is less than the second value, etc. And then we have these logic arguments, and, or, and not, that allow us to take Boolean variables and combine them in different ways. And we talked about and, or, and not before. What I want to introduce to you is this concept of hopefully my camera just came on, is this concept of truth tables, because they're very useful in trying to figure out whether your Boolean logic is doing what you want it to do or not. So let's quickly bounce over to the handy dandy whiteboard, and that is not on yet. Oh, I didn't put a battery in. The camera will never come on without a battery, turns out. Unless we're struck by a very low voltage lightning bolt, I guess. There we go. Nope, there we go. All right, so this is a little dark today, but it should be good. So let's talk about how to figure out Boolean expressions. Boolean expressions, you have like the AND operator takes two operators. So it's X and Y. The NOT operator only takes one, so it's a little simpler. Both of those are shown in there. But what you want to do is you want to take your X values and you want to enumerate true or false. I like to do true, true, false, false. And then you take your other values, Y, if there's two values. And now you do a different pattern, true, false, true, false. And if there were third, so every time we do this, you'll notice that the NOT only had true, false, true, 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 false. Things with two values have true, true, false, false. If you have more values, then the size of the table doubles every time. So, keep that in mind. And now we can look at what X and Y is. And what you do is you look across the table. True and true gives you true. True and false gives you false. False and true gives you false. False and false gives you false. So it's just a really nice shorthand for figuring out what the cost of your variables are, or what the value of your variables are given your inputs. So we can use this, and here's the truth table for AND is here. The truth table for OR is down here. NOT only has one argument, so NOT is much smaller, right? It only has false, true, true, false. I did my table wrong for NOT, but it should be false, true, and true, false, so you get all combinations. I'm sorry. Forgive me. This is the variable, false and true. These are the values, true and false. So if you have two variables, you have 4 entries. One variable, you have just 2 rows. And there are things called DeMorgans Laws, and these are kind of like distribution laws for knots within a Boolean expression. So not EX1 and EX2 is not EX1 or not EX2, and not EX1 or EX2, not the combination EX1 or EX2 equals not EX1 and not EX2. So these are important simplifications. They'll help you figure out some of your stuff, make your things much more readable. And there's also distribution laws, so that if you have an and out here, well, EX1 and EX2 or EX3 is EX1 and EX2 or EX1 and EX3. And with the or, it's, you know, EX1 or EX2 and EX1 or EX3. What you want to start thinking about is the or behaves an awful lot like a plus, right? So, and the and works like multiplication. So if you kind of look at your distribution laws, right, A plus B times C is A plus B times B plus C, right? Whatever I just said. A times B plus C is A times B plus A times C. And that's exactly what we're seeing here, right? And A times B plus C is A times B plus A times C, right? So these and works a lot like a multiplication operator, and or works an awful lot like a plus operation. And you are welcome to use whatever operations you are familiar with. These are just some really beginner ones to help get you guys in the notion of using Boolean operators and using you know, logic to figure out what you're actually writing when you write a specific piece of code. Okay. So we've kind of worked with this. When we have an if else statement, the block within the if and the block within the else can in fact be compound statements with ifs or whiles. So, you know, just make sure that as you're going through, you can trace through your code. The thing we want to look at here is, you know, if we have something like this, right? We have a block A, a block B. There's no block C, but we have a block D and a block E. Can you figure out, is there any block that is never executed? Is there a way through this without executing any code? So if we look here, right, in order to get within this block, EX1 has to be true. So if EX1 is true, we come within here. So if EX1 is true and EX2 are true, we execute block A. If EX1 is true and EX2 is false and EX3 is true, we execute block 3. What happens if EX1 is true, EX2 is false, and EX3 is false? Well, in that situation, we actually drop out of this loop, right? We come into this part of the expression when EX1 is true, but we never actually execute any pieces of code. Instead, we drop out to, you know, whatever block is down outside of the if. On the other hand, if EX1 is false and EX4 is true, we always execute block D. And if EX1 is false and EX4 is false, then we always execute block E. You know, so it's important that you be able to kind of trace through these and figure out what logic gets executed and where your actual code goes. And as with every other value, and we did this, by the way, I think we did this when we talked about Booleans the first time. You can store Booleans in an expression. Let's kill that. Right, so if that's not going to work. So enter a Fahrenheit temperature, we will say 23. And this is going to it's going to create a Boolean variable, is below freezing, and we can look at is below freezing. There's nothing special about a Boolean variable that prohibits you from, about a Boolean value that prohibits you from putting it into a variable. So make sure, you know, this will simplify your logic a lot. If you have complicated clauses, I saw a lot of this in the word portion of the homework 3, where we're analyzing sentences. Some people have some very complex if blocks. Consider using Boolean variables to kind of capture the state of different portions of your conditions, so that you can make your if statements a lot simpler. All right. So there are 2 things I skipped in this, and I'm going to go back to at least one of them now. I will have the random walk for you at the start of next class, and we'll kind of walk through that. It talks about random variables, and I want to show those, but it's not something that I can necessarily do in the next 2 minutes. Short circuiting I can. Remember our truth tables for and or, right? So this is the truth table for and it takes 2 values. And the only time it returns true is when both of those values are true. So if you have, like down here, ex1 and ex2, and ex1 is false, your program will not look at the value of ex2. Doesn't matter, right? So in particular, if we have something, we have a program, let's say def increment and true, or print and, we'll just print and true. And this print could be anything, right? I mean, this could be a list operation, could be something important, or it could just be a print statement. If we call this, it's going to print out here, and it's going to return the value true. Okay? So we can go print and true, and call it. It prints out here, and it prints out true. Okay? If we have let's set a variable to false, right? X and print and true, right? This is going to try to evaluate this expression. It's going to look at the Boolean here, and it's never going to execute print and true because X is false. On the other hand, if X were true, let's set Y to be true. If we execute Y in true, Y is true, so it can't make a decision just based on the value of Y alone. So it has to execute this part of the expression to get the value, and we should print out here. So that's called short-circuiting. Short-circuiting says if you can make a decision based on the first variable in one of these expressions, and or expressions, then you never execute, you never look at the second value, which is only important if you have side effects and things that have to happen in this expression. Okay, let's look at the or. If we look at or has a similar kind of value, except that or returns true anytime either of these values, ex1 or ex2, is true. So if ex1 is true in an or expression, we do a similar short-circuiting. As soon as we see one of these values being true, we execute the first one. So we can come in, we return true for the value of the or. So if we come in here and we say Y or print n true, right? That evaluates to true, but it doesn't print the here. Whereas with X being false, X or print in true, again, returns true, but it also executes. It has to execute the actual function to see that. All right. All right. I think that's more time than we actually have today. I caught up on everything except the random walk. We'll go over that next Thursday. Enjoy your day off. We will get you your grades as quickly as we can, and I'll stick around for another half hour or 15 minutes or whatever we have. We'll see you guys later.